Welcome to this next Reigate College Physics YouTube video. This time we're going to be looking at how to successfully complete momentum questions. In this particular example of how to answer momentum questions successfully, what we're going to do is take a question that is at the bottom of your TRA 3 lesson in the workpack. So we're going to be taking a situation where we've got two trucks, and what you can see is the question up on the right hand side of this video and also on the whiteboard at the moment. The first way to successfully, or first tip for successfully completing these sorts of questions, is to draw a diagram. Always draw yourself a diagram just to clarify what is happening and what we know in the starting place. So in this particular case, it says in a safety test, we have a 40-ton truck moving east at 15 meters per second. So take your diagram and draw on the direction in which the truck is moving and also mark on the velocity. In this case, you can see that I have assumed that east is to the right and that I have assumed that this is a positive value. So everything to the right is going to be positive. Anything to the left is going to be negative. So it says the 50-ton truck is moving west at a speed of 26 meters per second. Okay, and that is now a negative value. Okay, and that's what we're going to use, that negative value, in our mathematics at the moment. Just for the diagram, we're just going to use the arrow to show that it's going westwards. It doesn't matter what you choose as being your negative and positive direction, as long as you are consistent. Okay, so have it fixed into your mind as to what you're going to choose. So you've got the before situation here, so before the collision, and then after the collision, what happens is it says the 40-ton truck moves west at 15 meters per second. Okay, and we don't know what the speed of the 50-ton truck is. Right, so after we've drawn our diagram, we've marked everything on that we know, we then go about setting out our conservation of momentum equation. So we say that the sum of the momentum before the collision must equal the sum of the momentum after the collision. Seems simple, but it's always best to write it down just to focus the mind. Okay, next stage is we then break that up into the different objects that have momentum before and the different objects that have momentum afterwards. You probably think, oh, why are we doing it like this? It seems a little bit laborious. However, if you are logical and careful in these calculations and not scatter them over the course of the page, but keep them in one place in one line, you'll find that the answer will pop out so much more easily. So let's have a little look. So we've got the mass of the truck, 40-ton truck, times the initial speed of the 40-ton truck, plus the mass of the 50-ton truck times the initial speed of the 50-ton truck is going to be equal to the mass of the 40-ton and the final velocity of the 40-ton plus the mass of the 50-ton times the velocity of the 50-ton truck. Notice I'm using my U's and V's, U for initial velocity, V for final velocity. Now we put our numbers in. So we have 40 times 15. And now we put in our negative sign to say that our 50-ton truck is moving westward. So we've got our 50-ton truck moving at 26 meters per second. Then we have our 40-ton truck moving at 15 meters per second. And now look, that's going west. So let's put that negative sign in there. And then finally, we have the 50-ton truck moving at some unknown velocity. So what we're going to do now, let's do the calculation. So we've got 600 minus 1300 equals minus 600 plus 50b. Let's take our minus 600 over to the other side so that I have essentially 1200 minus 1300 equals 50b. So I then end up with minus 100 equals 50v. And so v is minus 2 meters per second. What does that minus tell us? That minus sign in that final answer means that it must be travelling to the west. So it didn't matter that we didn't assume any particular or assign any particular direction to the 50-ton truck. We just left it as it was. We assumed it was positive. The answer comes out negative, which tells us it's moving west. So you don't need to make any assumption at that point. And so there you have it. Here are your key stages to solving a momentum question successfully. Number 1, draw a diagram. Number 2, equate momentum before, momentum afterwards. Then link that to all your individual objects that are moving, but on one line. Do not scatter your individual momentums across the page and then try and combine them later. That way, madness lies and you won't be able to get the correct solution. Write it all out in full. Just take it nice and steady. No need to rush to get then minus 2 meters per second west.